Hello, everyone. My name is Jewel. Today, I'm going to present the project for my CSC360 data analysis class. My presentation topic is the world's coffee rating, and I'm going to share my screen. Issue description. Coffee is a critical export crop for many developing nations, and its market value depends strongly on its overall rating. The total cup score varies based on geographic, environmental, and post-harvest factors such as altitude, species, and processing method. Understanding which factors strongly influence quality can support sustainable farming and global competitiveness. There are two questions I would like to explore. The first question is, which factors most strongly predict total cup points? Total cup points are overall cupping score in the dataset. Second question is, do coffees from certain countries constantly scores higher than the other countries? The data source I was using was from dataset Tidy Tuesday, July 2nd, 2020 coffee ratings. The source was from Coffee Quality Institute and Specialty Coffee Association. And here is the URL for the dataset. And if you are interested in it, I will share my presentation in our forum. You can use the URL to access to the raw data. And I was using the standard read CSV file in R to import the dataset. Documentation. The dataset is documented in the Tidy Tuesday repository with full description of variables such as altitude mean meters, aroma, flavor, processing method, species, and total cup points. A data directory is provided in the repository, which is very helpful for me to understand what does it mean for each variable, for each column. So it's useful for me to choose, to select, to filter what type of data I need. Description of the data. So first of all, I upload the library tidy words, and then I read the CSV file into the new data frame called coffee. So I got 1,339 rows and 43 columns for this data set. And I use a structure function to see what columns are in the data frame. And we can see here are the variables: aroma, flavor, balance, color, and so on. And we can also see here that the variables type, we have character type and number type. If it is numeric type of the variable, and after I applied summary function to the data frame, and I get minimum, maximum, first quartile, third quartile, median, and the mean numbers of each of these columns. But if the column is character type, we won't get this analysis. Here is the summary for our new data set, coffee. The data set contains 1,339 rows and 43 columns describing coffee samples evaluated worldwide. Key variables include total cup points, country of origin, variety, processing method, altitude mean meters, aroma, flavor, acidity, moisture, and so on. Before analyzing the data, I did cleaning and preparation of the data. So I choose country of origin, species, altitude, mean meters, processing method, aroma, flavor, aftertaste, acidity, body, balance, and total cup points as the columns, the variables necessary for my data analysis. And also, I use the drop NA function to remove the missing values in the data set. And then I created a new column called average sensory, which add up all the 6 sensory scores and divide by the number of sensories. And when I view the new data set, it's called Coffee Clean, I get still over 1,000 rows and the columns I selected, which is 12. And we have character data type, for example, country of origin, and we have many numeric data type, which are used to calculate the sensory rate. So the cleaning steps include first, selected only necessary variables based on the questions you were choosing. Second, remove the rows with missing values. And third, created average sensory score based on the 6 sensory attributes. Here, you can see here. Final results. In order to answer the first question, which factors most strongly predict cup quality, I use 4 variables and explore their influence on the total cup points. First of all, is average sensory score versus the total cup points to see how average sensory score influence on the total cup points. I use June points plot, and then also June smooth for seeing the relationship between the average sensory score and the total cup points. So we can see from the plot clearly that it is a positive correlation. That means the higher average sensory score, the higher rated coffee. The second variable I use to examine the influence on the total cup points is species. I use a box plot to show which species is has a stronger influence on the coffee quality. From the box plot, we see that the Arabica coffee gain higher scores than Robusta coffee constantly. Because the box encloses the middle 50% of the data, and it can view clearly about that. The third variable I use to examine the influence on the total cup points is the altitude. I did a filter of the altitude mean meters, between 400 meters to 3,000 meters. That is because I realized that there are some mistakes when people enter the data into the raw data set. I saw some altitude is over 15,000 meters, which is not correct because this might be when people enter the data, it was wrong. It is higher than Mount Everest, so it's not true. And plus the second reason why I filter this altitude is because most of the coffees are grown between the 400 meters and 3,000 meters. So I want to examine the data belong to that group. I use Geom Point and Geom Smooth, and I use the linear model to show line regression line here. Then we can see clearly the relation between the altitude and the total cup points. So from this plot graph, we can conclude that coffees grown at higher altitudes, particularly for the Arabica varieties, tend to receive higher quality scores. So the pink is the Arabica coffee, and the blue is the Robusta coffee. But the blue dots is only clustered here. So in contrast with the Arabica coffee, the Robusta coffee cluster at lower altitude and exhibit lower average scores. The last variable I use is the processing method. And I use this variable to examine how it influences on the overall coffee quality. And what I do is, first of all, I group the data by processing method, and then calculate the mean number of total cup points for each processing method. And then I've made the scatter plot to see which method produce the highest score of the coffee. So we can see here the popped natural honey method tends to give the highest coffee score, which is 83. According to the mean score comparison, popped natural honey processing yields the highest average cupping performance in this sample. Washed or wet coffees follow closely behind, while natural dry coffees produce lower average scores despite occasional high scoring examples. This suggests that honey processing may offer a strong balance of flavor development and quality control. The second question I would like to examine is, do coffees from certain countries constantly score higher than the others? What I was doing is, first of all, I group the data by country of origin and then calculate the mean score of total cup points for each country. And then I create a new column to count sampler size per country by this new column N, and counts how many rows coffee samplers exist for each country. And then in order to keep the analysis more accurate, I choose the country with more than 5 samplers. So the less sampler size could make the result misleading. That's why we use the n greater or equal to 5 as a data cleaning method to get a new analysis. So then I choose the top 15 countries to do analysis. And when I plug into the bar chart, it shows that the top 15 countries which has the highest mean cup score. This is a bar chart of top 15 countries by rating. Using the cleaned coffee dataset, we computed the mean cupping score for each country and selected the top 15 countries with at least 5 valid evaluations. The bar chart shows that Ethiopia ranks highest in mean coffee quality, followed closely by United States, Kenya, Uganda, and Colombia. These results highlight the dominance of East African and Latin American coffee origins in the specialty coffee market. Countries such as Costa Rica, El Salvador are also constantly well regarded, aligning with global export perceptions of high-altitude Arabica production regions. The United States appears in the top of rankings, although it is not the major coffee producer, but the dataset includes a special coffee grown in Hawaii, which is well known for premium high-score Arabica beans. That's why we can see here the United States ranks high. So conclusion, by analyzing the variables influence on the overall coffee quality, we can conclude that altitude, sensory quality, species, and processing method strongly related to coffee rating scores. And high sensory quality Arabica beans processed by pulped natural or honey method perform best. And certain regions such as Latin American and East African coffee constantly leading in rating. And because this analysis is time limited, so if we can further our work to analyze more factors which influence the coffee general rating, we can do incorporate climate factors and examine sustainability metrics. So this is my presentation. Thank you for watching and have a great day.